Yes. Hi viewers. Today we are going to see about the involute curve. Okay. This is another engineering curve where we are going to study this particular unit 1. So today we are going to see how we are going to draw an involute curve. So here in involute curve, it's a simple basic problem how we are going to draw an involute. And especially it's a simple example. We are having some technical terms for drawing the involute, winding or unwinding or wound. These are the main technical words they used to give in involute problems. Because from a drum we are going to unwind a coil, or a drum a wire is going to unwind. So these are the logics we used to apply for the involute cases and that. So in your question paper they doesn't give the draw a involute curve directly, means they may give these technical terms, it will be there. Okay, from this we can able to analyze. So this problem comes under involute curve. So here I am simple problem I am going to give. It's a coil unwound from a drum of 30 mm diameter. Let me take 30 mm diameter from the coil. It has been drawn, and I am going to find out this value, and the diameter will be 30 mm. Okay. Okay. Then we are going to draw the locus of a free end of the coil for unwinding through an angle of 360 degree. So it's a full rotation, and we are going to draw a tangent and normal for this particular problem. Okay. So only thing we are going for this one. Main thing is we are going for the involute curve of diameter 40 mm. So as usual procedure here, some important things we need to keep in your mind. So draw a circle of a 30 mm diameter. Okay, let me draw a circle of 30 mm diameter and divide the circle into 12 divisions. As usual procedure I am going for it. So here I have divided. Okay, I have divided the circle into 12 divisions now. So next step what I am going to do is I need to give the numbering. The numbering is very important. So here what I am going to do, I am going to start the numbering from at this point. This is the point number 1. Okay, point number 2, the straight line is third point, right? The straight line is third point. So I will ensure that. Yeah, this is 3, 4, 5, 6, 7, 8, 9, 10, 11, and the last one, this is the 12th point. Okay. Okay. Next step what I am going to do is I am going to draw a baseline, a horizontal line here. From the point 12, just draw a baseline. So this line, this 12th point I am going to give the name as, let it be A, and another one is B. And the total length of this line is equal to pi d. Okay, pi into 30 mm. What is the diameter we are going to get? That is the value. So the value you will get it as pi d here. It will be 94.26. So 94.26 mm. That is what we are going to get. And if I am going to divide this value by 94.26 in terms of 12 division. Okay. So in terms of 12 division, if I am going to divide this value, okay, pi d is equal to 94.26, and if I divide the value you are going to get, it will be 7.85, right? This will be 7.85 mm, or I can say 0.78 centimeter. So in this problem we are getting like 0.78 centimeter. Let me take, since it is greater than value, I will get approximately 0.8, right? I will take it as a 0.8. If I am going to divide this line AB into 0.8 centimeter of 12 divisions, right? What does it happen now? We cannot able to take 0.78 exactly. We can able to take 0.8. Some we are rounding off it to here. So some minor corrections I have done. So the last point, definitely it won't be like in a 0.8 mm. It will be less than that. Or else we can need to go for that line, divide this line AB into equal number of segments. That part we need to go it. Anyhow, here in this figure I am not showing for that. I am going in approximation manner. Okay. So you guys better you can draw it like that particular concept, so that you can divide the line number into equal number of segments. I hope I already discussed those things in my previous video. So you know how to divide a line into equal number of segments. So I am not going for that. So you can do it and you can go it also. So So right now what I am going to do is I will take point 8 and I am going to divide these line segments here. So here if I am going to divide, so this is the first point, first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this is 11 and the let it be 12th point. Okay, here we may get, you may get a little bit smaller than this. So anyway I am giving the namings, and due to little bit space issues I am drawing like in this manner. Okay. Okay. Now next step what I am going to do is, so here I have captured all the divisions. Okay. The next step I need to draw a tangential line from each and every point. Guys listen, this is the center point is O. Okay. This O1 line we have drawn, right? For this O1 line just draw a perpendicular line in such a manner it should be tangential to this. See here. And for this O2 just draw a perpendicular line. For this O3, O3 is a horizontal line, so its perpendicular line 100%, it will be a vertical line. O4, O5, O6, O6 is it's a purely a horizontal line, no doubt about that. And O7, O8, and O9 is it's a purely vertical line, and O10 and O11. You got it? So like this we need to draw a perpendicular lines from each and every point of the circle. Now my next step is what I am going to do is, guys just listen, this point is A, right? This point is A. This A, and here also I given 1, 2, 3, right? Instead of this you give 1 dash, 2 dash, 3 dash. So the naming should be unique, right? So give the naming like in this manner. Okay. So let me take the distance, this point A to 1 dash. What is that? A to 1 dash. In this baseline I am going to take the distance. Let me take here and let me mark it here. A1 dash is equal to, take the distance of this A1 dash, okay, and place your compass at the point 1. You have drawn one perpendicular line, right? You cut an arc at that particular line and just give that particular line point, that particular where it cuts, that point as name. So now I can say A1 dash is equal to 1P1. Am I right? Can I say like that? Okay. And similarly go for A2 dash is equal to, now you place your compass at the point 2. You cut an arc at this corresponding line. Okay. And A3 you cut an arc like A4, A5. A2 dash you may get it like 2P2. So this is P1, this is P2, and this is P3. So like this the naming will be there. At last I will put the naming. So each and every distance we need to take, and you may get an arc like in this manner, and you will finish it off. Okay. And the last point definitely it will reach us at the 12th one. Okay. Now I am going to join this curve in such a manner. Let's see. So this is the first point arc, and finally this point it has to touch with this 12th point. So from the 12th point I will narrate the curve, okay, in such a manner. You are going to get like in this manner. So join all the arcs where it cuts. Maybe while drawing the arc my places will be a little bit different here, but you will get it perfectly. Okay. So join all the arcs where you got it. Okay, you will get a wonderful shape of the curve, involute curve. So like in this manner, and it will start ends with the end 12th point. So this is the normal shape of the curve. Once if you draw the curve, try to erase the unwanted lines, then only your figure looks good and nice to see it also. So please don't forget it, and whenever you are going to draw all these tangential lines, it should be very thin. You should not draw it very darker. So ensure that it should be very thin. Okay. So this is the procedure for drawing a involute curve. Okay. Now in addition to this we need to draw a tangent and normal, right? That's one important thing we need to have. So let me choose any point on the curve. Let me take this point P. Now the next step what I am going to do is, from the P point join P to O. Okay. Join P to this center point. Now measure the length of this line OP. You take that midpoint of that line. For example, let me take here and let me give the name as O1 for example. Now place your compass at the O1, take O1P as radius or O1O as radius, both are right, and draw a thin semicircle. You will get a semicircle wonderfully. Okay, draw a semicircle. Okay, now here what does it happen now? While drawing this semicircle will cut the circle at one point. We will cut the circle. See here the semicircle is coming here and it is cutting here and it cuts at this particular point. Am I right? So you capture this point. This point is very important now. Now from here you just draw a join this particular point towards this point. And I am going to give this point name as, let it be N. This is a N because I am going to draw the normal now. That is the main reason I am giving here. So giving this point name as N, just join N towards this point P and extend this line little bit upwards. So this point is called as a N and dash. Okay, so N and dash is the particular point. Okay, N and dash is the normal line here. Now for this I need to draw a tangential line. The tangential line should be perpendicular to the normal line. Hope you know that. So place your protractor and mark at an angle of 90 degree, and this tangential line, it has to pass through this point P. So definitely the tangential line will go like in this manner and give the name as T and this name as T dash. Okay, and this name as T dash. So this TT dash is the tangential line. Okay, so that's the value for the involute curve, how to draw an involute curve and a tangent and normal. So finally just write it down. TT dash is a tangent and N dash is a normal, and mark the dimensions, the circular dimensions here. Here in this problem the dimension will be, it's 30 mm, right? So close it and mark the dimension as dia 30. Okay, that's the end of the problem. Thanks for watching guys. Have a nice day. Please do like, share and subscribe my channel.